Hi, today I'm going to be talking to you about tangent approximations and all of their various applications. I'm making this video by popular demand. Many students struggle with this topic. If you are one of those students watching this video, please try out all the problems before watching me solve them. You can watch someone solve a million problems and it won't make you any better. Well, it'll make you a little better. It won't make you better enough. So here we go. Without further ado, maybe watch me solve this one, but none of the other ones. Write an equation of this tangent line. How? How can I do that? I need to know two things for an equation of a line. Equation of a line should make you think of point, and it should make you think of slope. Two things, a point and a slope. So, my point is given. Check. What's the slope at that point? Well, I can find out what f prime of x is. You almost that up. 3x squared. And look how I'm labeling it, and I can find f prime of 1, which is negative 3. So that's the slope. So my answer to A would be something along the lines of this. Look how I'm using point-slope form. I'm so proud. Use this tangent line to approximate f of 1.1. How? Well, using that equation, I know that the y values on that tangent line are equal to 3 minus 3. And we're saying, as we're close to 1, the values on this line, the y values of this line, are close to the y values of this function. So because of that, f of 1.1 is approximately equal to 3 times 3, 1.1 minus 1. C, what's the actual value? F of 1.1 is actually equal to negative 1.1 cubed plus 4. So since this is our first problem, whoa, bad parentheses there. I'm sorry, folks. Clean that right up for you. F is approximately this. 1.1 minus 1 is 0.1. 2.7. But F is actually negative 1.1 cube. Ignore it, it's just an operating system. You should be getting what I'm getting, 2.669. So the point is, these two really close values. Close enough. Alright, next. Make a large copy of this graph. Draw the tangent line. Write an equation of this tangent line. Label a point. Go ahead and do all of that. Give yourself 5 minutes, or however long it takes. Really try it. Really write it out on a separate sheet of paper. Don't just think about it. Do it. On paper, with pencil. 3, 2, 1. Here's my giant graph. Okay? I'm going to draw this tangent line, freehand even. Okay, I can do better than that. Wow, pretty good for a second attempt. Write the equation of this tangent line. Well, I know it has this point. How can I find the slope? Well, on this graph, f prime of this graph would be 2x And f prime of 1 would be 2. So importantly, the equation of that tangent line, y minus 1 equals 2 times x minus 1. And for this unit, it'll be really helpful to have it solved for. 1 plus 2 times x minus 1. Label a point on my tangent line with x coordinate of 0.9 as point A. Okay. Use my equation to approximate f of 0.9. So D. F of 0.9 is approximately 1 plus 2 times 0.9 minus 1, which this thing is equal. That's approximate, this is equal. 0.8. Label point B as the actual point. That's right here. See how they're close enough together? The idea, everybody, is if I really blew this up, you can see that they're actually disagreeing. But they're not disagreeing by very much. What's the value of f of 0.9? E. F of 0.9 is 0.9 quantity squared, which is 0.81. Use the same tangent line to approximate f of 0.6. So going back to the tangent line, f of 0.6 would approximately be equal to 1 plus 2 times 0.6 minus 1. 0.2. But I know f of 0.6 is actually equal to 0.6 squared, which is 0.36. So consider how close these are versus how close these are. And the reason for that is at 0.6, there's the actual point, and here's my point. The gap is increasing as I get further and further away from the point of tangency. Alright, now comes the actual application problems. 3, 2, 1. Sorry. Try it out. Pause the video. I counted down too early. What are you waiting on? Really pause it. Really try it. The graph gave you a point. How could you use this point to help you? How could you pick this point? Because 25 is really close to 26. And why is 25 helpful here? Because I can actually do the square root of 25 by hand. This is a non-calculator section. Here we go. I have a point. I need a slope. dy dx. Let's start change color halfway through. 1 over 2 root x. I want the slope at that point, which would be 1 over 10. Okay, so the equation I'm getting, y minus 5 equals 1/10 times x minus 25. Or, in the helpful way for this unit, 5 minus 1/10 times x minus 25. So, if we're looking at root x, this is what everyone had a hard time with. If you wrote this, you're still having a hard time. If you wrote 5 minus 1/10 square root 26 minus 25, you're having a really hard time. You really need this video, so keep watching. If the function is root x, what is x at this point? X is 26. So I'm looking for, I'm so sorry. So f of 26, not root 26, but 26, because 26 is what's replacing x. Stop. 5 minus 1/10. The way you'll know if you're on the right track is if you're getting something close to this value. Okay? That's enough of a closeness. You could have gotten 4.9 precisely. Okay. Here's a graph. Try it again. Try to answer 4 and 5. Pause the video, write on a piece of paper, try to get 4 and 5. 3, 2, 1. That's my slope. That's my point. Y minus 30 equals -9 times x minus 3. Y equals 30. So f of 3.1 is approximately 30 minus 9 times 3.1 minus 3, which is 29.1. Find the actual value of f of 3.1. For 5, it cannot be determined. There's no info on f. We don't actually have the formula that was used to get this function. But we know it's close to 29.1, and that's the power of approximations. Oftentimes in engineering, you'll come up with data that you don't necessarily know the function that produced it. But you'll have one firm data point, and you'll know the rate that function is changing, and you might be able to get an approximation. Okay, try it. Do your best. Pause the video, try it out. 3, 2, 1. Did you try it? I hope to God you tried it. Point. Need a slope. Guess what? You better have used the product rule. First times the derivative of the second. All of that's the derivative of the second. Plus the second times the derivative of the first. Okay? I'm evaluating this when the x coordinate is 5. See? You're going to get 25 over 4. Yeah, over 4. Plus 4, which is 41 fourths. That's the slope. Y minus 20 equals 41 fourths times x minus 5. Y equals 20 plus 41 fourths. X minus 5. F of 5 and 1/5 is approximately 20 plus 41 fourths. 5 and 1/5 minus 5 is 1/5. That's 20 plus 41 twentieths. 441 twentieths. I'm just having fun at this point. It's like 22.05. Pretty good approximation. I wonder what it actually is. 5.2 times squared. Oh, snap. It's pretty close. Great. Alright, this is actually close to how you might get this question on an actual test. So try it out, do your best. Come back when you're done. 3, 2, 1. Instead of using the actual area formula, approximate the area using the local linearization of the area formula. Local linearization, tangent line. Okay, a lot of students got stumped here, I know. So here we're going to find a tangent line approximation. So A prime equals 2s. So A prime when s equals 8 is 16. So now I need a point. 8 comma 64 s squared. So the tangent line approximation would be something like area minus 64 equals 16 times the side length minus 8, or 64 plus 16 times side length minus 8. So the area when s equals 8 and 1/16 would be approximately 64 plus 16 times 1/16, about 65. See, that's all there is to it. Find the approximation if the side length is actually 7 and 5/16. So A of 7 and 15/16, not 5/16, is approximately 64 plus 1/16 times, this will end back to be negative 1/16 now, which is equal to 63. So, if we were 1/16 off in a positive direction, that's what the possible measurement area means. If I was overestimating, my area would be 65. If I was underestimating, my area would have been 63. The actual is between 65 and 63. That's it. That's all there is to it. Because that's how off I could be. That means the maximum value of my measurement would have been 8 1/16, in which case the area would have been approximately 65. The minimum value of my measurement would have been 7 15/16, which would have been an area of 63, approximately. Go for it. Try it. It's really straightforward. 3, 2, 1. Here we go. So, if I want to approximate f of 8.01, I want to use x equals 8, close to 8.01. Try it out. If you haven't finished this, if you had trouble getting started, there you go. That's a huge help. F of 8 would be 2. F prime of x should be 1/3 x to the negative 2/3. F prime of 8, 1/3 8 to the negative 2/3. And I know so many of you have a hard time with that. 1/3 over 8 to the 2/3. Dirty slash fractions. Do the third power first. 1/3 times 1/4. 1/12. Okay. That's f prime of 8. So I have my point. I have my slope. Change color. Y minus 2 equals 1/12 x minus 8. Y equals 2 plus 1/12 x minus 8. So f of 8.01 would approximately be 2 plus 1/12. 8.01 minus 8. That's it. Without a calculator, no one could ask for more. Done. Ooh, awful. Try it out though. It's not that bad. Really try it. 3, 2, 1. We gave me a point. The question is, what's the value of the slope at that point? So I need to find dy dx. As soon as you see something like that, you should think implicit differentiation. Product rule. Chain rule. Derivative of 19 is 0. If you didn't get that, try again. That's worth a huge amount of points. Because that takes a lot of skill. That product rule, that chain rule. Solve for dy dx yourself, you try it. I'm taking my time, trying to be real clear. I hope you are also. So I get dy dx x plus 4y cubed okay? And that's the derivative of y with respect to x. So now I know how to get the slope at that point by replacing all the x's with 1s and all the y's with 2s. I'm just going to go right for it. Negative 3 minus 2 over 1 plus 32. Negative 5 over 33. That's hideous. So I'm just checking my work because I think that's really awful. I don't see anything wrong. So my tangent line, here's how I label that. Y minus 2 equals negative 5 over 33 times x minus 1. Solving for y, like you have in every single problem so far. And when x equals 1.1, what the heck? So, oh man. Why are you being so annoying? Oh, Spotify's trying to open now? (1.1) y would be approximately 2 minus 5/33 1.1 minus 1. That's it. All done. Next. Use a calculator to find the actual y coordinate. Show the equation I'm solving. Okay, try it out. Pause it. Here's the actual equation. How can you find the actual y coordinate? Really think about it. When x is 1.1, how can you solve it? Please try. 3, 2, 1. So, I'm just going to start by copying this equation down. Check that it's right. Alright, when x is 1.1, we get 1.1 cubed plus 1.1 times y plus y to the 4th equals 19. And here's how I do it, guys. I have a lot of people scaring me, asking me how do I solve an equation using my calculator. If you're using an 84, this is the best way to do it. Just like that. So one's going to go in for y1, the other's going to go in for y2. That's the equation I'm solving. On the actual AP test, I'm not going to write these two things. Because it's obvious. It's obvious by the time you're doing the AP test. It needs to become second nature. But I'll graph that half in in y1. Just ignore that my calculator looks different than yours. It's okay. X plus x to the 4th. Mr. Leven, why are you using x's? This says y's. Your calculator doesn't know the difference. It's okay. 19. Hey, if it's going to be looking for 19, 19 should probably be in my window. In fact, I only really need to see stuff that happens around 19. So let's go from 15 to 20. Okay, y min, y max. Now this should be bigger. So let's search in that window for this. Oh, snap. Look at that, too. Now, it's possible there's more, but only one of these is happening when x is 1.1. Right? Let's trace it out. 1.1. Boom. Wait, what? Oh, I'm sorry. I'm so sorry. Ignore what I said. So we have positive y, we have negative y. Trace. Find the value of the intersection. We want this number to be next to 20. Let's go with 16. Bam. Guess. 1.98. Three decimals. 1.984. Or 1.983. How close was it? How close is that? Let's find out. Oh my gosh, I really hate Windows sometimes. 2 minus 5/33 times, it's 0.1. Spoiler alert. Oh snap! Look at that! That's a great approximation. Oh my. Oh me, oh my. And that's the equation we're solving. Okay. That's all they're asking for. Now, how do I know it's not the other y? How do I know it's not... I know it's not this one because that y value, if you'll indulge me, is close to -2. And we're interested in y values close to the +2 one. Okay, this is what told me y greater than 0, right there. We know we're looking for a value close to 2. That's subtle though. Most of you'll just pick the positive numbers just because. Alright, given this function, go for it. Try it on your paper right now. 3, 2, 1. Alright, so I want to approximate this value. So many people think that means, oh, x equals 2 1/6 to the cube. That's completely wrong. If that's what you did, try again. 3, 2, 1. I hope you paused it and really tried. Okay, what's close to 2 1/6? X equals 2. If x equals 2, my original function y would be 8. And dy dx, which is 3x squared, dy dx, evaluated when x equals 2, would be 12. So y minus 8, 12 times x minus 2. See how this number is close to 2 1/6? So y equals 8 plus 12, x minus 2. And our approximation is, I can write like this also, 2 1/6 cubed is approximately equal to 8 plus 12 times 2 1/6 minus 2, which is 10. Okay? Find the actual value. That's a calculator question. 2 plus 1/6. That's what it means, everybody. 10.171. Pretty far off. Okay. That's all there is to it. Okay, this question was hard. Please pause the video right now and try as hard as you can. 1, 2, 3. 420, ha 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 ha. Oh my god, it's so funny. Alright, interstate travelers traveling that much, blah blah blah. At noon, she notices her speed. At noon, 60 miles per hour. Her position is 240. So, if t equals 0 at noon, I have an t coordinate, a position coordinate, and I have the velocity at noon, which is 60. And velocity is the derivative of position, right, folks? So I have a linearization. Y minus 240 equals 60 times time minus 0. So y equals 240 plus 60t. Okay? Approximate her position at 2. Approximate her position at 2. So if noon is 0, 2 p.m. is t equals 2. So S sub 2, her position at 2, is approximately 240 plus 60 times 2, which is 360. Approximate her position at 10:30 a.m. So here's the issue everyone had. If that's 0, which is noon, and here's 2, just so I can measure, 2 p.m., where's 10:30 on this number line? 10:30 is over there. What's the t coordinate? Try it. Oh, it's negative 1.5. I can't tell you how many people completely lost their minds. S of negative 1.5 would approximately be 240 plus 60 times negative 1.5, which is 150. What is the domain for my linear function? Really weird question. Non-standard question. The domain, well, it'll work until our function tells us she's back at her house. So, when would her position under this approximation be 0? That would be negative 4. Approx position equals 0. And when will she be done her drive? At 420 miles. I know. Ha 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 ha. It's so funny. Oh my god. If only math was always this funny. That would be 3 hours in. Approx position equals 420 for life. Ha 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 ha. I'm pretty frustrated. Alright, that's that. This is hard. If you hadn't needed a lot of help on this, if you couldn't do most of these questions, really look at your work. That's why I asked you to write it down. If you couldn't do most of these questions, you need to try it again. Non-negotiable. I appreciate your hard work. I appreciate you watching this video. Please come see me in person if you're struggling. If you need to try it again, watch it 2 days from now. You'll see an improvement. I guarantee it. Keep up the hard work. Let me know if you have any questions. Have a great day, and I'll talk to you soon. Bye-bye.